Hello, 7th grade. We are in week 11, and we're going to be talking, first of all, first part of the week, about metamorphic rocks. By the end of this lesson, you should be able to explain the formation of metamorphic rocks, how they're made, how they're created. So this is a picture of a metamorphic rock. This rock here in this photo is a banded gneiss. Now, gneiss is spelled G-N-E-I-S-S. The bands are made from different minerals. The light bands are more felsic, and the dark bands are more mophic. The minerals separated due to heat and pressure, and the waviness of the bands also shows how the rock was hot enough to alter, to change. It was not hot enough to melt all the way, however. Metamorphic rocks start off as some kind of rock. The starting rock can be igneous, sedimentary, or even another metamorphic rock. Heat or pressure then change the rock into a metamorphic rock. The change can be physical, chemical, or it can be both. During metamorphism, a rock may change chemically. Ions move in or out of the mineral. This creates a different mineral. And new minerals that form during metamorphism are more stable in the new environment. Extreme pressure may lead to physical changes as well. Now, if these physical changes are exerted on the rock from one direction, the rock forms layers. This is foliation, or we call it folated. If the pressure is exerted from all directions, the rock does not show this foliation. It doesn't have the layers, but it's still a metamorphic rock. Okay? There are two main types of metamorphism, contact and regional. Contact metamorphism results when magma comes in contact with a rock. So the rock is already there, and the magma works its way up through the soil and gets close to this rock. The rock changes because the magma's extreme heat warms it up. So here on this picture, on the left, hornfels is a type of rock that's created by contact metamorphism. And on the left, picture B, hornfels are so hard that it can create peaks like the Matterhorn in the Alps. So that entire mountain is made of hornfels, which is a metamorphic rock. This is metamorphic rock that came closely in contact with liquid rock, and that was the reason why it warmed up. So that is contact metamorphism. There's also regional metamorphism. Regional metamorphism occurs over a wide area. Great masses of rock are exposed to pressure from rock and sediment layers on top of it. The rock may also be compressed by other geological processes. If the rock is buried deeply, it may experience high temperatures. So on the left, we see regional metamorphic rocks often display layering, which again we call foliation. Regional metamorphism with high pressures and low temperatures can result in, on the right, we have blue schist. Okay, blue schist is a result of high pressures but low temperatures. Okay, metamorphism does not cause the rock to melt. So we don't go from metamorphic rock to magma, but there is a lot of heat and pressure. And it only causes the minerals to change by heat and pressure. If the rock melts completely, it will cool and become an igneous rock. Now, here's another picture of hornfels. Hornfels is a rock with alternating bands of dark and light crystals. Hornfels is a good example of how minerals rearrange themselves during metamorphism. The minerals in hornfels separate by density. The result is that the rock becomes banded. Gneiss forms by regional metamorphism from extremely high temperature and pressure. So in summary, any type of rock, igneous, sedimentary, or metamorphic, can become a metamorphic rock. Needs to have heat, pressure, and sometimes some chemical interaction with it as well. Contact metamorphism occurs when a rock is altered by heat from a nearby magma vent or pocket, but it's not actually liquefied. It doesn't melt the rock. Regional metamorphism occurs over a large area when a rock is buried and compressed. So contact metamorphism, mostly heat. Regional metamorphism, mostly pressure. You can have combinations of those. So how'd we do? Are you able to explain the formation of metamorphic rocks? If not, feel free to go back and check that video out again. But if you can, feel free to jump right in and start on the next assignment. Have a great day.